Today, what we're about to reveal is nothing short of mind-blowing. Picture this: a moon adorned with roads and landing pads, a lunar landscape transformed into a cosmic superhighway. Why is this so incredible, you ask? Well, not only is it scientifically fascinating, but it's a leap forward for lunar exploration. In fact, the moon's surface is about to become our playground in the sky, all thanks to the astounding plan by scientists to create roads on the moon. But how does it all work? Stick around as we dive into the extraordinary facts behind this lunar road construction. So let's get started. Picture this: a barren lunar landscape where, in the not-so-distant future, roads and landing pads crisscross the surface, making lunar exploration more accessible than ever before. It may sound like science fiction, but it's closer to reality than you might think. Basically, tiles could be created on the moon in a relatively short time with simple equipment. Yes, you heard that right. Researchers are exploring the possibility of creating lunar tiles, or paving stones, using an unexpectedly simple approach. It's all about making the moon more homey for us. But you might wonder, how is it even possible? Here's the key: lunar dust. That's right, lunar dust could be the raw material for moon roads and landing pads. Now let's delve deeper into the nitty-gritty. Lunar dust, contrary to its serene appearance, is a dark gray abrasive material. It's primarily composed of volcanic rock, ground into fine particles over millions of years due to cosmic impacts and radiation. Unlike Earth, the moon lacks wind and water to erode its soil. As a result, many particles have razor-sharp edges, which makes moon dust quite the adversary for space exploration. So, how do we turn this potential hazard into an asset? Well, that's where science gets really exciting. Scientists are contemplating a process that involves concentrating sunlight using enormous lenses. By doing this, they believe that they can fuse lunar dust into paved roads and landing pads. The concept is so ingenious, it's reminiscent of a giant solar-powered lunar oven. These lenses would harness the sun's energy, directing it onto the lunar surface, where it would essentially bake the lunar dust into sturdy, rock-like tiles. Now, you might be thinking, that sounds too good to be true. Has anyone actually tried this on Earth? And the answer is a resounding yes. Scientists are using our very own planet as a testing ground for this lunar road-making technology. Experiments on Earth have involved using lasers to blast simulated lunar soil. These tests aim to replicate the conditions on the moon and determine the feasibility of creating solid structures from moon dust. The results so far have been incredibly promising, laying the foundation for lunar exploration breakthroughs. But why should we care about lunar roads? Well, they hold the promise of making space exploration and potential colonization of the moon a lot more accessible. Picture astronauts being able to travel more efficiently and vehicles and spacecraft having reliable landing pads. These lunar roads would be game changers in our quest to unlock the moon's mysteries, and perhaps as a stepping stone for further human exploration of our solar system. Imagine what it could mean for future lunar bases, mining operations, and even tourism. Now, let's unravel the mysteries of moon dust. It's not your average dust. Lunar dust is a special breed. It's electrically charged, which makes it particularly sticky. Imagine the challenges this sticky, abrasive powder poses for lunar landers, spacesuits, and even our very own lungs if inhaled. So why do we care about this electrified dust? Well, there's a cosmic solution in the works. As we dream of lunar exploration and colonization, a dilemma arises. How do we protect rovers and equipment from the abrasive clutches of moon dust? The solution? Paved roads on the moon. But there's a catch. Lugging building materials from Earth to the moon comes at a staggering cost. So what's the workaround? Scientists are turning to the moon itself as a source of construction materials. Enter EAC-1A, a fine-grained material developed by the European Space Agency as a lunar soil substitute. Imagine it as the moon's doppelganger, but conveniently available right here on Earth. The big question is, can we transform lunar dust into solid rock using focused sunlight? The answer, my fellow space enthusiasts, is yes. In a new and exciting study, Scientists, including the ingenious Juan Carlos Gines Palomares, set out to harness the power of the sun to create moon roads and landing pads. Think of it as a cosmic construction site. The scientists experimented with laser beams of varying strengths and sizes, some packing a punch of up to 12 kilowatts in power and about 4 inches wide. So, what did they discover? The results were nothing short of astounding. By focusing these powerful laser beams, they were able to melt lunar dust into triangular, hollow-centered tiles. Each tile measured approximately 9.8 inches wide and up to 1 inch thick. These remarkable tiles can interlock, creating solid surfaces over vast areas of lunar soil, paving the way for roads and landing pads across the moon's surface. The implications of this breakthrough are out of this world, literally. Paved lunar roads and landing pads could revolutionize lunar exploration. Imagine rovers gliding effortlessly over stable surfaces, human habitats anchored securely, and spacecraft touching down with precision. But here's where it gets even more exciting. By relying on lunar resources for construction, we can drastically reduce the costs and logistical challenges of lunar missions. It's a giant leap forward in making lunar colonization a reality, and it could rival the rich lithium fields of South America and Australia in its significance. Previously, researchers suggested that the key to lunar roads might lie in harnessing the raw power of sunlight or colossal laser beams to fuse lunar soil into robust structures. But here's the kicker. Prior experiments were like baby steps compared to what we're about to reveal. They never produced blocks as substantial as what we've got in store for you, and they certainly never played with light beams this enormous and powerful. So, how do you focus sunlight to create a beam on the moon that's strong enough for this lunar transformation? Well, the answer is all about the size of the lens. Think big. To generate a beam as powerful as the ones used in these groundbreaking experiments, scientists had to calculate a lens roughly 5.7 feet, 1.74 meters in diameter. That's right, it's quite the cosmic magnifying glass. The magic formula? Intense sunlight, that colossal lens, and lunar soil. With this trifecta, the possibilities are endless. Now, let's talk about the practical side of this celestial construction. The next step is to analyze how well these moon-borne tiles can withstand the forces of rocket thrust. Could they serve as reliable landing pads for spacecraft of all sizes? It's a question that's sparking excitement in the scientific community. And here's the fascinating part. Future experiments could involve testing these tiles under simulated lunar conditions. That means working in environments without air and experiencing the reduced gravity found aboard parabolic flights. Working under these conditions is essential to demonstrate the feasibility of the technology before it can be applied on the moon, notes Gines Palomares. It's all about ensuring that the lunar roads we're dreaming of are as dependable as they are groundbreaking. The researchers behind this cosmic innovation detailed their findings in the journal Scientific Reports on October 12th, and it's safe to say they've opened a new chapter in lunar exploration. Imagine a future where lunar roads crisscross the moon's surface, providing a stable path for rovers and safe landings for spacecraft. In short, the moon, our closest celestial neighbor, is no longer just a distant dream. It's becoming a canvas for human ingenuity and innovation. The idea of creating lunar roads using sunlight and lunar soil is not only inspiring, but incredibly achievable. It's a testament to our curiosity, our determination, and our unquenchable thirst for cosmic exploration. So, what are your thoughts on the concept of lunar roads? Are you as awestruck as we are about the future of lunar exploration and the potential of these cosmic highways? Share your thoughts in the comments below, and don't forget to like, share, and subscribe for more mind-blowing space-related content.